Welcome to the DIY Honda Garage channel. DTC P0118 refers to the Engine Coolant Temperature ECT Sensor 1 experiencing a circuit high voltage condition. This indicates that the voltage signal from the ECT sensor is above the expected threshold, leading to incorrect engine temperature readings. The ECT sensor is essential for the engine control unit, ECU, to optimize fuel injection and ignition timing based on the coolant temperature, affecting the overall engine performance and emissions. Located in the engine block, this sensor detects the coolant temperature and sends this information to the Powertrain Control Module, PCM. A malfunction in this sensor or its circuit can cause various engine performance issues and even trigger the engine warning light on the dashboard. It's crucial to address this issue promptly to maintain vehicle performance and efficiency. The ECT sensor plays a pivotal role in measuring the temperature of the engine coolant. This component typically contains a thermistor that changes resistance with temperature variations, sending a voltage signal to the PCM. The voltage signal from the ECT sensor is supposed to be between 0.5 to 4.9 volts under normal circumstances. The PCM utilizes this data to adjust the air-fuel mixture and ignition timing for optimal engine performance. Malfunctioning of the ECT sensor, poor electrical connections, or issues within the associated wiring can cause erroneous voltage readings, which may trigger the DTC P0118. It is crucial to ensure the integrity of the sensor, its connections, and the associated wiring to avoid performance issues. Several factors can lead to the DTC P0118. A faulty ECT sensor itself may produce an abnormally high voltage reading due to internal damage or thermal failure. Another likely cause is poor electrical connections. Corrosion, dirt, or loose connections can interrupt the signal transmission between the ECT sensor and the PCM. Additionally, there may be an open circuit in the wiring that connects the ECT sensor to the PCM, which can prevent proper signal transmission. It's essential to carefully inspect the sensor, its connectors, and the wiring prior to replacement. Doing so ensures that the root cause of the issue is accurately identified and addressed. When DTC P0118 is triggered, drivers may observe several symptoms. One of the most noticeable indicators is the illumination of the check engine light on the dashboard. This warning signifies that there's an issue affecting engine management, often leading to poor engine performance, such as a decrease in acceleration and overall responsiveness. Additionally, drivers might notice increased fuel consumption because the vehicle's engine may run inefficiently without the correct coolant temperature readings. If these issues persist without attention, they could lead to long-term damage to the engine and associated systems. Furthermore, fluctuating temperature gauge readings may also point to a failing ECT sensor. The first step in troubleshooting the P0118 code involves confirming the issue. Begin by turning the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Next, utilize the HDS Honda Diagnostics system to check the ECT Sensor 1 parameters. You will be specifically looking for a voltage reading from the ECT sensor. It should be below 4.92 volts in normal working conditions. If the voltage exceeds this threshold, the failure is verified and you're advised to proceed to the next troubleshooting step. If the reading is normal, it suggests an intermittent failure, warranting a closer inspection of the electrical connections for any signs of looseness or corrosion. In this step, you will focus on isolating the fault to the ECT sensor. Start by turning the vehicle to the off lock mode to ensure safety while working with the electrical system. disconnect the ECT sensor 12P connector, which houses essential electronic connections for the sensor. To simulate the sensor signal, connect terminals A and B with a jumper wire, effectively creating a direct connection. Turn the vehicle to the on mode again and use the HDS to check if the voltage registering from the ECT sensor now falls above 4.92 volts. If this condition is met, it confirms that the ECT sensor is faulty, requiring replacement. If not, it indicates further investigation into the wiring and other components is necessary. Here, we focus on checking the wiring system connecting the ECT sensor to the PCM. First, ensure that the vehicle is in the off-lock mode before performing any electrical checks. Remove the jumper wire from the ECT sensor 12P connector to revert to normal conditions. Turn the vehicle to the on mode once again while keeping the ECT sensor still disconnected. Use a multimeter to measure the voltage between test points 1 and 2, where test point 1 is the ECT sensor 12P connector number 2, and test point 2 is body ground. If you observe a voltage reading around 5.0 V, it indicates that the circuit is functional and connected correctly. Thus, proceed to the next troubleshooting step. If the voltage is not within expected levels, this will necessitate further examination. In this step, you will be checking the continuity of the SG2 wire that connects the ECT sensor to the PCM. Begin with the vehicle in the off-lock mode to ensure safety. You will next need to jump the SCS line with the HDS, maintaining this condition for more than a minute. After this, disconnect the PCM connector E80P to isolate it from the system. Use a multimeter to check continuity between test point 1, ECT sensor 12P connector number 1, and test point 2, PCM connector E number 78. If continuity is confirmed, the SG2 wire connection is intact, allowing you to check for service bulletins pertaining to the symptoms or substitute a known good PCM. If this resolves DTC P0118, then replacing the original PCM is warranted. Should there be no continuity, an open circuit must be repaired. This step centers on verifying the continuity of the TW wire, which serves as another link in the ECT circuit. Just like the previous steps, ensure that the vehicle is powered down. Jump the SCS line with the HDS and maintain this for more than a minute to create a stable environment for testing. After this, disconnect the PCM connector E80P. Again, employ a multimeter to check continuity, but this time between test point 1, ECT sensor 1 2P connector number 2, and test point 2, PCM connector E number 52. If continuity exists, the TW wire is intact, and you should consider referring to any authorized service information or substituting a known good PCM to see if that resolves the DTC. If there's no continuity, an open circuit must be identified and repaired to restore proper functionality. After completing all necessary repairs for DTC P0118, it's essential to verify that the issue has been successfully resolved. Start by using the HDS to clear any diagnostic trouble codes recorded in the system. This step resets the system's condition and allows for the detection of any unresolved issues. Following this, conduct a test drive under varying driving conditions to ensure the vehicle performs correctly and that the ECT sensor operates as intended. After the test drive, recheck for any new or reoccurring DTCs using the HDS. The absence of any new trouble codes indicates that the repairs were effective and the vehicle is operating correctly again. To prevent DTC P0118 from reoccurring, engage in regular preventive maintenance measures. Inspecting the wiring and connectors associated with the ECT sensor should be done routinely, as wear and tear or exposure to elements can lead to corrosion and connectivity issues. Periodically check the ECT sensor to ensure that it is functioning correctly and that the readings it provides are within expected parameters. Address any signs of corrosion or loose connections immediately to mitigate risks of short circuits or miscommunications within the electrical system. Keeping these components in good condition will help ensure that engine management remains optimal and performance issues are minimized. In summary, DTC P0118 indicates an ECT sensor 1 circuit high voltage issue that can significantly affect engine performance. Understanding the description of the fault helps in efficient troubleshooting efforts. It's important to follow a systematic troubleshooting approach, starting from verifying the problem, isolating the sensor, and checking wiring continuity to ensure all aspects are addressed. Performing thorough inspections of the sensor and associated connections is essential to catch any potential issues early. By engaging in diligent preventive maintenance, you can minimize future risks of encountering this DTC again, thus keeping your vehicle running smoothly and efficiently. Prompt attention to issues like these is key to maintaining vehicle health. Please like and subscribe to the channel. See you next time.